enough, and I like know what it really goes, and so I can just get where it'll catch up eventually. Still, so, no, it's definitely nice. Thank you. Sure, he's recently having tonight. So I'm basically explaining control over it. Yeah, here. This is just like, well, it's not familiar. That's good. It's different words.
Okay. We're going to start notes for derivative inverse functions. So trig derivative inverse functions. So page 25. Your packet. Oh, no, that's fine. That's fine. I got extra ones. So I have your quizzes pretty much all graded. I just have to enter them in the grade book. I hope to give them back to you tomorrow. Um, but we're pretty much done with in terms of major topics, because what remains are just these derivative rules. If we understand product, quotient, chain, implicit, and how they all can be or recognize when to use those, then that's really the main thing. Now it's just a bunch of derivative rules that we have to learn. But in terms of the processes for the test, we've covered all that already. So now it's just a matter of these rules. So the inverse of a trig function may be indicated using inverse f with a prefix or with a prefix arc. So you may see inverse sine of x. You may also see that arc sine of x. These are interchangeable, so just recognize that we need to be able to look at it and know that they're the same things. So with these, we never have to worry about what these graphs look like. Uh, as far as these inverse trig functions, we just have to know their derivative rules. Now, if you notice, I've organized them the same way as the sine, cosine, tangent, cosine, cotangent, cosecant, because there's nice patterns as well with them. These look complicated, and they, relative to the other derivative rules, they are more complicated. But the good news is that there's really only three of them. There's only these three rules, because if you know what these three rules look like, these are just the negative versions of the ones that are to the left of them. So, so here are the three main ones. We have arc sine, arc tangent, arc secant. They're all going to have u prime in the numerator. So arc sine is just u prime over. And then the denominator, they all have 1 and u squared. It's just in different order. So arc sine is 1 minus u squared. And the u prime just represents whatever is inside the parentheses of my arc trig function is my u value. And u prime is just asking for the derivative of whatever is inside that parentheses. Let me zoom in a little bit. But it's a little dark. Let me see if I can. Okay, arctangent also has that same format. There's also the u prime above. There's also 1 and u squared below. But it looks like this, u prime over 1 plus u squared. Arcsecant looks the most complicated, but it still has these features. It still has u prime and u, but it's going to look like this, u prime over, and it's absolute value of u, square root of u squared minus 1. Okay. I have a way of memorizing this, but let me, we'll go through and make sure we know how to use the rules first, and then I'll come back and talk about these memorizing these rules. But if you can know these three, then the nice thing is the arc cosine, arc cotangent, arc cosecant, you can just copy them over. The one on the left, just put a negative in front. So arc cotangent, arctangent are basically the same derivative. It's just a negative version of arctangent. Arc cosecant is a negative version of arc secant. So whatever is inside the parentheses is our u value. Okay, so let's see if we want to find the derivative of arc sine or inverse sine of 3x, what goes in my numerator? Yep. And the denominator is just 1 minus 3x quantity squared, which is 9x squared. So once we have the rules in front of us, it really is as straightforward as just, okay, u prime, find the derivative. If it's a u, I just copy down the exact same expression. So see if you can try 2 and 3. I think they should be pretty straightforward. Inverse tangent of 2x squared, u prime over 1 plus u squared. So u prime is just 4x. U squared is just my entire denominator, or sorry, my entire u value squared. So 4x squared, 4x to the fourth power, sorry. And then for arcsecant, you got that absolute value in that denominator. As far as reducing and canceling out, you can cancel x's and coefficients even if something is stuck inside the absolute value. The only thing with absolute value is if there's any leftover variables after you reduce, then we need the absolute value there. So really, that's the only thing. But you can cancel across. You can cancel something inside the absolute value with something that's not outside. That's not inside the absolute value. So that's just demonstrating that fact for 4 and 5. If I want to reduce arcsecant, I can cancel across numerator denominator. I can cancel what's inside the absolute value, but sorry, we should have an absolute value here as well. Okay, and then domain of inverse functions. I think it's just good to know. I don't know if we're actually gonna have to know this in heavy detail. But arc sine domain is from negative pi over 2 to pi over 2. Cosine's domain, inverse cosine's domain is from 0 to pi. Sorry, domain is from, sorry, the range. Range is from 0 to pi, and then the range is from negative pi over 2 to pi over 2. Okay, evaluating each function at a given value. So first we're going to find f prime, and then from f prime we can plug in our x value and then use inverse trig to get us to our answer. So first, sorry, it's just evaluate the function. So we're just going to practice evaluating the function. So arc sine of root 3 over 2. So this is really a representation of theta. So if this feels like it's messy to interpret, you can always rewrite it as saying, okay, this is basically saying sine of what theta value is due to root 3 over 2. And this feels more familiar to us because this is the way that we've talked about unit circles. So sine is positive sine is going to be in that first quadrant. So theta is going to be pi over 3. If I plug -2 in for x, that's same inverse cosine of -1/2 is equal to theta. In other words, cosine of what theta value is equal to -1/2. We know theta for cosine is going to be between the first and second quadrant. So negative, that means the second quadrant. So second quadrant variation of pi over 3 is going to be 2 pi over 3. Positive is always first quadrant, so 1 over root 3 pi over 3. Sorry, pi over x, yeah, pi over 6. Okay, next up, these are just practice problems. Most of them are the new rules that we've just learned. There is an older rule like cosecant of 6x. So, but the rule for that is just cosecant becomes negative cosecant u cotangent u times u prime. Okay, so let's see if we can go through the rest of this page. 11 and 12, you're going to be finding slope, finding order pair, point slope form. So we already know how to do all these processes. It's just, every time we learn a derivative rule, we're just going through all the, make sure we can apply all the old processes that we've learned. Okay, try those. And I'll go over each of them once you guys have a chance to try these. So after a few minutes, I'll show 1 through 4, and you guys keep working, and then eventually I'll show up to the bottom of the page. I'll just have the rules here in case these are easy access for you. Flip back and forth. Right. Yeah, so I'm going to go back and I'm going to update all the rules that we've learned. So instead of just x, I'm just always going to replace x with u times u and u primed. And that way we're always looking for that chain rule portion for every problem.
Oh, so that wasn't there when we moved them.
Right, because we haven't learned chain rule yet. But now that we have chain rule, we're just always, most problems are going to be chain rules. So I just like to rememorize the rules in terms of chain rule.
Oh, I got.
Yeah, no, you've learned everything right. You just instead of x's, you replace x with u, and then just include that u front. But everything is still essentially the same. Everybody okay? 1 through 4. Any questions? 1 through 4. If you're good with 1 through 4, if you're good with 5 through 7, go ahead and try 11 and 12. So 11, there's that additional step of finding not only the derivatives, but then from the derivative, you need to find the slope. From the function, you need to find the order pair, and then do point slope form. Any questions up to number 7? Any questions with 11?
Oh, where did you get the one at top?
This one here?
Yeah.
So the rule for arc sine of x or arc sine of u is u prime over square root of 1 minus u squared. And my u value is x, so x is derivative just. Are we okay finding order pairs, finding slope, point slope form? Number 19, you're going to need a little bit of implicit to get to the derivative. So remember, if y is stuck inside my equation, still going to find the derivative like I normally would. Just have to make sure I attach that ui dx when we take care of that arctangent derivative. Any questions with 11 or 12? Okay, I'll work number 19 out. So it says arctangent of y is equal to natural log of x. So we know the derivative of arctangent of y, or arctangent of u, is u prime over 1 plus u squared. So you could say, y prime or dy dx divided by 1 plus y squared. But what I did was, I didn't want to look at this above, so I just pushed that in front and I made it 1 over 1 plus y squared times dy dx. You didn't have to, I just felt maybe that was easier to look at, but either way, we had to. Multiply by the reciprocal, divide that 1 over 1 plus y squared over, get that dy dx by itself. Once we have that by itself, then we have our derivative. Okay, any questions here? I just want to go over how I memorize these Trig rules, because we know that if we just take care of these three, then these three are no problems, right? These are some negative versions. But this is how I go about thinking. I look for patterns, and that kind of helps me remember these rules. So, but let's look at these rules here. What do you notice about the numerators? They're all what? Yeah, they're all going to be u prime. So if we just put down all the common things, then that makes it less to memorize, right? Because we just know, okay, they're all going to be u prime. And the denominator, all the denominators have what? 1 and u squared. So that's nice, right? We know that, okay, every derivative is going to have those features. So this is what I do. I start with the easiest one. The easiest one is the arctangent. There's no absolute value. There's no square root. There's no minus sign. It's just a plus sign. So that's what I start with. Next up, I go to the hardest one. Arcsecant, I know it's got the absolute value. It's got the square root. So I know that it has that absolute value of u. But sometimes what I get stuck with is I don't know which, I know there's a minus sign, but I don't know which one comes first. Is this the 1 or is it the u squared? So what helps me is I know it's going to be the u squared minus 1, because I know the u's are next to each other. So if I know the u's are next to each other, then that helps me remember, okay, it's not 1 minus u squared, it's u squared minus 1. And if I can figure out this order, then I can take it and flip it for my arc sign. My arc sign is going to be a little bit different. It's going to be different from this. It's got the square root, no absolute value. It's got the minus sign. So if I can figure out this order, then I can figure out this order as well. So that's how I go about it. So hopefully that helps you memorize this a little bit easier. It doesn't feel as intimidating when there's all these common parts to it. Right. Or really, it's just if I can memorize this, and then I can just make some slight adjustments to get to arcsecant and arcsine. Let me show you the fact. Okay, so we've learned, or we've almost learned, all the derivative rules. Tomorrow we're going to go over just the remaining logs and exponential rules. But just want to kind of show you real quick. If you can turn to page 45. So 45, I organize all the rules. This is the key. If you flip to the back, it's the blank version of it. So the blank version is a way for you to kind of practice down the line when you're reviewing for the quiz. So this is how I've remade the derivative rules, or this is the way that they present the derivative rules in the textbook. So notice, these are all the rules that we've learned. Just instead of x, you're gonna say u and u prime, and that way you're always setting yourself up for looking for that chain rule. Even if there's no chain rule, worst case scenario, sine of x is just cosine of x times 1. So you're still looking for that u prime each time. So when we talk about rules now, I'm just always going to use that notation u, because before we learned this before chain rule, but now after chain rule, we're going to just expect that most problems are going to have that chain rule portion inside your function. So natural log of x is not just 1 over x. Natural log of x, natural log of u is u prime over u. And then e to the x is not just e to the x, e to the u times u prime. So really it's replacing every x with u and then just including a times u prime for all your rules. Yes.
Why do we replace the x with the
How do we replace the x?
y?
Y. Yeah, so before we would have a derivative that would just be y is equal to sine of x. Right? But now you're gonna have problems that are more complicated. It could be like sine of 3x squared. Right? But we can apply the same rule for both of these. Right? The derivative of sine is just cosine of u times u prime. So pretend like this is the u value. So sine of x becomes cosine of x times u prime times 1. So you don't have to put that 1 there, but you're always looking for that chain rule. So here sine of u becomes cosine of u. Now this needs it, right? This is times 6x. So before we never looked at that 1 there because x is always going to be 1. But now most of your problems are going to be more involved. But even if it's not involved, this rule still works for simple cases that if it's just sine of x. Right? That u prime just doesn't appear because it's times 1. Okay, any questions? Okay, so for the next 5 or so minutes, can we get started with the AP practice, which is part of your homework? So let's go to page 29. And let's see if we can get through a few problems and also just make progress with your homework. I'll show the answers after you guys have a chance to try it.